Hi everyone, my name is Bing. I'm currently based at the University of St. Andrews, and today I'm going to share my preliminary result of my modeling study, explaining human handedness, combining king selection and the parent of origin effects. Firstly, I always ask myself why to study human handedness, because it's interesting. The frequency of left-handers in human population is around 10%. And this is quite stable and substantial across different regions if we exclude the effects of culture. And there is also a slight sex difference between males and the females. Males are more likely to be left-handers than females. And also we know left-handedness is highly heritable, but twin studies has only found the genetic components only account for about 25% of the variance could be explained. So lead us a question, the missing heritability. In its most general sense, laterality is widespread across animal kingdom, but the population bias of handedness is quite special in human beings. And also, laterality, the population bias laterality in human beings may suggest there's some human featured evolution, such as the evolution of language. So people possess many hypotheses to explain the frequency of left-handedness. So generally, there should be some costs of being left-handers. Otherwise, it will remain in the 50% of the population. And also, it never goes to zero. And this means there could be some benefits for left-handers. And they could not be frequency independent. Otherwise, they will go to 50%. So one of the game theory hypotheses is the combat hypothesis or fighting hypothesis. It posits by being a left-hander, you gain the benefits of winning more likely to win a fight by creating a surprise because people are more used to fight with right-handers. In this way, the general game theory hypothesis all deal with social interactions. And in evolution, we know king selection plays a very important role in social evolution, but unfortunately, it is completely ignored in game theoretical treatments of left-handedness. So I will explain what is king selection. We all know individuals can pass the gene directly by reproduce themselves. And also, they may also help the relatives pass the genes, even sacrifice themselves reproduction. In this way, they increase their inclusive fitness by directly pass their genes, pass their relatives' gene. So in this way, we could model how relatedness between individuals that could influence the handedness. And take combat hypothesis as an illustration. We know that in this hypothesis, left-handers may gain the benefits, and this also harm the fitness of other individuals. So this is a selfish trait. And when we consider the relatedness between individuals, it makes no sense to be left-handers if all your surrounding individuals are your relatives. In this way, we may predict generally the probability of developing as left-handers will decrease as relatedness increase generally in population. And second, we know there are sex difference between different sex in left-handers. So how could this be? Even there is no sex difference in fitness of being left-handers, there could be sex difference. And the situation could be there are sex bias dispersal. For example, like there are two patches and females are more likely to disperse than males. In this way, we create a relatedness asymmetry. Then females are more relatedness, they are less related to each other than males. In this way, they are more likely to develop the selfish traits. And also, we would expect males could have a more probability of developing as left-handers if they take part in fight more frequently than females. So in our model, if you only model the sex bias dispersal without considering the sex difference in fitness effects from fighting, we could still see the sex difference between male and female of the probability of being left-handers. So in the left part of the figure, it shows the situation where females disperse more than males. In this way, females, they are less related to each other than males. So they will have higher probability of developing as left-handers. While in the right part of the figure, it shows male disperse more than females. So females would have a lower value of developing as left-handers than males. Please note, even the frequency here is close to 10%. It doesn't show the exact simulation of the number. It just shows the pattern of sex difference. And now we look on the most complex situation where different sets of genes within individuals, they disagree with each other, which means they have different optimal value of express their own value. So we know our genes, they have two parts. One is inherited from our mother, and the other from our father. So will they always agree with each other, or sometimes they can disagree with each other? The answer is sometimes there will be conflict. But when would this happen? We will look into this in relatedness asymmetry. So there are many ways of creating asymmetry of relatedness. One of them is, again, sex bias dispersal. So guess in certain society or tribes, there's still female bias dispersal. Guess your mother and your aunt disperse from other places to your family, and then here would be the family place, and then we will see the same color shows the same gene, like the mother and the aunt, they have different genes. In this way, we will see the relatedness between you and your cousin would be different from the perspective of maternal origin genes and paternal origin genes. In this way, there will be a disagreement of the optimal value of different set of genes. Here we know through maternal origin genes, the relatedness should be lower than that through paternal origin genes. And in this way, we would predict the genes inherited from the mothers will favor a higher value of left-handers if we think they are selfish traits. So what will happen if they have different value? We are an individual, we only have one phenotype, but if different set of gene has different optimal value, there should be some conflict. And how does this conflict end? So now I will show the situations. When there are sex bias dispersal, we can see the orange line shows the maternal origin genes, and the paternal line is blue, and in the center is the individual genes as a whole. So we, just like the sex difference, we show different set of genes could have different optimal value of developing as left-handers in female bias dispersal and male bias dispersal. Even there is just marginal difference between different set of genes, we could predict this will end with one part of the genes be totally silenced and the other expressing at their optimum value. But how could this be? According to the loudest voice prevail principle suggested by David Haig, it is that when the different set of gene has different optimal value, say the maternal origin one prefer like 10.2% of being left-handers, while the paternal origin gene prefer a slightly lower value of left-handers. Then they will express in different way. The maternal one increase and the paternal one decrease. And again, they disagree with each other to an end, which the maternal origin gene express very high and the paternal one just silenced. And in the final stage, the maternal origin gene will just express at its own optimal value, with the paternal one just silenced. However, when we consider a different gene, it inhibits the phenotype of left-handedness. Sorry, I forgot to mention the previous one is a promoter of left-handedness. So if it's the inhibitor, then still they have different optimal value of being left-handers. Then the paternal one will increase the expression because they want to suppress the individual to be the left-handers. And finally, the maternal one will be silenced, and the paternal origin gene will express at its optimal value. Under these predictions, we can make further prediction of the pattern under epimutational situations, such as gene deletion. So when the gene or genetic factor was deleted, and if they are just the silenced one, we can see this doesn't influence the final result of the phenotype. But if the deleted one is the expressed gene or genetic factor, we can see if it's still female bias dispersal, if the maternal origin gene prefer a higher value, when they are deleted, this would make the individual being less likely to develop as left-handers. And when it's the inhibitor being deleted, we would express the individual being more likely to be left-handed. So I will summarize as 3 take-home messages. First, handedness could be mediated by gene selection. So the more relatedness between individuals or by different set of genes, the less likely they will express the selfish trait. In this case, is the left-handedness. So the second one is the loci underpinning handedness could be imprinted depending on the relative dispersal of different sexes, and depending how the trait, whether the trait is selfish or altruistic. And the last one is sex-specific expression of handedness would happen even there is no sex difference in the fitness results. Thank you for your attention. That's it. I will be happy to answer your questions.
Thank you very much. We have time for one very quick question.
I'm just wondering, when you say about trait being selfish, in terms of kin selection, what exactly do you mean? Because you could think of any of these processes as being selfish in terms of reproduction of genes into the next generation, or do you mean this in terms of like a sort of sexual antagonism kind of effect?
This can be one of the situation, and it can just be the competition between same-sex individuals, even females. Let's guess, in the Asian human society, females also combat to have their breeding place or for food, and we should assume this will influence their fitness. But it may be not true for handedness. It's just the exploration for the general game theory hypothesis. Thank you.
So no other questions. Thank you very much, Dave.
Thank you.